All right, let's jump right in. Today, we are taking a deep dive into the policy workflow for Cisco's software-defined access. We're going to break down how Cisco DNA Center takes your simple business goals, what we call business intent, and translates them into the actual nitty-gritty configurations that secure and run your entire network. So here's what we're going to cover. We'll start with the big idea behind policy automation. Then we'll get into the core components, starting with the modern identity-based way of doing things, and then look at where the traditional IP-based controls still fit in. After that, we'll talk about network-wide segmentation with virtual networks, and we'll finish up by looking at how you can make sure your most important traffic always gets top priority. Okay, let's kick things off with the whole reason SD Access exists. It's really about changing how we think. For years it's been about logging into one box at a time, typing commands. It's tedious. This is about moving to a system that understands what you want to do, and then it automatically figures out how to do it on every single device.
And this is where the magic really happens. You just define your policies in one place, in DNA Center. You say things like, contractors can't access our production servers, or video calls are always the most important traffic. DNA Center then acts as this brilliant translator, creating all the specific command line code for every single piece of hardware you have. It's a huge time saver, and honestly, it cuts down on so many of those little human errors that can cause big outages. Now let's get to the heart and soul of SD Access policy, securing your network based on who someone is, not just where they plug in. In today's world, with people roaming around on laptops and phones, the old security models just fall apart. This is a complete shift in focus from where to who.
So, the key idea here is we are done tying security rules to things like an IP address or a VLAN. Those can change in an instant. Instead, we use group-based policies. And these are enforced using something called Scalable Group Access Control Lists, or SGACLs for short. And you should know, the whole system really relies on a tight partnership with Cisco's Identity Services Engine, or ISE. Think of ISE as the brain that handles all the identity and authentication stuff.
So let's walk through what this actually looks like. First, a user plugs in or connects to Wi-Fi and gives their username and password. The switch sees this and immediately calls up Cisco ISE. ISE checks the credentials, says, yep, this person is an engineer, and then it pushes the right policy down to that exact switchboard. And just like that, from that moment on, that user gets the engineer policy, and it follows them everywhere they go.
Now to make this work, we need a couple of building blocks. The first one is called the Scalable Group Tag, or SGT. The absolute best way to think of this is as a digital sticky note. As soon as a user is authenticated, this little 16-bit tag gets attached to every single packet of data they send. It's a label that says who they are, and it has absolutely nothing to do with their IP address.
And here you can see what those labels or scalable groups look like inside DNA Center. Now these are actually defined over in ISE, but they get pulled in so you can use them to build policies. And look at the names. Contractors, employees, BYOD. They're logical, they make sense to the business. These are the groups we're going to build our security rules around. Okay, so if the SGTs are the who, then access contracts are the what. A label on its own doesn't do anything, right? You need a rule book that says what that label means. And that's exactly what an access contract is. It's just a collection of rules, like a reusable access list that says what kind of traffic is allowed or not allowed. These contracts can be super simple, like you see here, a deny IP or permit IP. Or they can be incredibly specific, saying things like, allow web traffic on port 443, but nothing else. The main thing to remember is that they are reusable. You build them once, and you can apply them all over your policy matrix.
And here's my favorite part, where it all comes together, the policy matrix. This is literally a picture of your business intent. You have your source groups down the side and your destination groups across the top. To create a rule, you just find where they intersect and you drop in a contract. So in this example, you can see that little red box. That's a policy that says traffic from the contractors group going to the employees group gets hit with the deny IP contract. It's that simple and that visual.
So let's just put this side by side for a second to really let it sink in. On the left, with SGTs, it's all logical. It's about who you are. It doesn't care about your IP address, and your security follows you wherever you roam. On the right, that's the old way. Your security is bolted down to a subnet or a physical port. If you move, your security breaks. It's a night and day difference in flexibility.
Now, identity-based policy is amazing, but let's be real, we don't live in a perfect world. Sometimes you still have to control traffic the old-fashioned way. Maybe you're talking to a legacy system that doesn't understand SGTs, or you have a very specific filtering need. Sometimes the IP address still matters.
IP-based access control in DNA Center is, well, it's pretty much what you'd expect. It works just like a classic ACL. You're filtering based on the usual suspects: protocol, source IP, destination IP, and port numbers. And the building blocks will feel familiar too. Instead of scalable groups, we use IP network groups, which are really just lists of IP subnets. And we use the exact same access contracts we saw before to define the actual permit or deny rules.
Okay, let's zoom out for a minute. So far, we've been talking about micro-segmentation, right? Controlling traffic between specific groups. Now, let's talk about macro-segmentation, creating completely separate, walled-off networks for different communities. And in SD Access, we do this with virtual networks, or VNs.
The best way to think about a virtual network is like building virtual walls inside your physical network. It's a totally self-contained, logical network that runs on top of your existing hardware. By default, traffic in one VN is completely blind to traffic in another VN. This is just perfect for keeping your corporate users, your guests, and maybe your sensitive IoT devices in their own secure sandboxes.
This diagram here shows the concept perfectly. Down at the bottom, you have the physical underlay. That's all your real switches and cables. But built on top of that, we create these separate logical overlay networks. You can see the examples: a VN for your regular users, a totally separate one for guests. Each one operates in its own little world.
Okay, we've covered security pretty well, who can talk to whom. Now let's shift gears and talk about performance. You know, how do we make sure that a massive file download doesn't make our CEO's critical video call all choppy? That's where application policies and quality of service, or QoS, come in.
First things first, with any QoS policy, you have to be able to identify the traffic. And this is awesome. DNA Center recognizes over 1,400 different applications right out of the box. From there, you just group them into logical sets that make sense for your business. For example, you might put Microsoft Teams and WebEx into a bucket called Collaboration Apps. This lets you build policies around business functions, not just IP addresses and ports.
So, once you've identified your apps, you have to decide how to treat them. Queuing profiles let you do just that. It's basically you telling the network, hey, no matter what's going on, I want to reserve at least 10% of the bandwidth for my voice calls and 15% for video, while maybe capping that less important traffic to just a few percent. It's like creating express lanes for your important applications.
Now that queuing profile is perfect for your internal network. But what happens when that traffic leaves your building and goes out over the internet? Your ISP has their own QoS system. That's what service provider profiles are for. They act as a translator. They take your internal priority markings and remap them to match what your service provider expects. This is absolutely crucial for making sure your QoS is respected from end to end.
So to put it all together, the application policies are where you combine all these pieces. You define the what, which apps to prioritize, using your application sets. You decide the where, which network sites to apply this policy to. And you dictate the how, using those queuing and service provider profiles to actually enforce the rules.
In this quote right here, it just says it all. The point of all this isn't to just tweak QoS on a few switch ports. It's about creating one single, cohesive, intent-based QoS policy that stretches across your entire enterprise, from your main campus, over the WAN, and out to all of your branches.
So we've covered a ton of ground, from identity-based security with SGTs all the way to application-aware QoS. The final question I want to leave you with is this. Now that you've seen all these building blocks, think about your own network and your own day-to-day work. How would shifting from manual box-by-box configuration to this kind of intent-based system truly